Hello, I'm Lavinia Heaton, and today we're looking at increasing and decreasing functions. Now, if I draw for us a curve that looks like this, I think it's pretty easy for you to tell that we're increasing as we go up here, and at this point we kind of stop increasing and start decreasing. And that's pretty intuitive for us to say we're increasing here and decreasing over here. Okay, let's look at what a math definition of increasing and decreasing might look like. Okay, a function is increasing on an open interval if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2 for any x sub 1 and x sub 2 in the interval. Now you might kind of get tongue twisted over that, but I want you to look at what a definition looks like in mathematics. It is saying to us that the first y is less than the second y anytime the first x is less than the second x for any x that we have in that interval. Let's go back and look at that for a moment. We said that we were increasing as we went that way. So let's look at our x's here. If this is x sub 1 right here, and this is x sub 2 right here, and we're increasing, let's see. This says whenever f of x sub 1 is less than f of x sub 2. So here is our y sub 1 right here. And sure enough, as we go up here to x sub 2 and we get the second y, its height right there is certainly greater than the height of this y sub 1 for the point x sub 1, y sub 1. And then when we look at decreasing, it's the same thing. Our first y is larger than the second y whenever the first x is smaller than the second one. In other words, as we go from left to right, our y's either go up or down depending on whether we're increasing or decreasing, and the y's stay the same if we have a constant function. So let's work a problem or two with this concept in mind. All right, we want to say where something's increasing and decreasing. So let's just draw us a little grid here to use and fashion us our own problem. Let's say that this curve peaks out at -1, 1. And it looks maybe something like this. All right, it's probably not hard for us to tell that we're increasing right here like we were a few minutes ago, and that we're decreasing right here like we were a few minutes ago. But how do we describe this? Generally, we describe this in interval notation. Now think for just a minute. What makes the graph go up? The x's or the y's? All right, the y's make it go up, don't they? We go up based on the y. So if I say increasing, decreasing, or constant to you, you already know what the y's are doing. So we're going to describe where this happens by the x's because those are the things we don't know when we say increasing, decreasing, or constant. So back to our screen here, we see that we're increasing and we want to describe it by the x's. So let's underline our x so we won't get sidetracked. Well, what's this x right here? Must be negative infinity because it keeps on and on going. We don't actually hit a number, so we say we're headed toward negative infinity. So we're increasing from negative infinity until we get to -1 for x. Infinity and negative infinity always get a parenthesis. -1, it may surprise you, is going to get a parenthesis because where we change at the peak or the valley, we consider it neither increasing nor decreasing. So we put an open parenthesis to show that it's not included. I have seen one textbook where they used a bracket, but I disagree with that, and most books do. All right, decreasing, let's describe it by the x's. We start with -1 for x, and we keep on and on and on going, so we're headed toward positive infinity. Infinity gets a parenthesis, and the top dog is neither increasing nor decreasing, so its x gets a parenthesis, and it's constant nowhere, so there are no constant intervals here for us. All right, let's do another one here. Erase what we have and draw us another little graph here to work on. All right, let's this time say that we have a graph that's somewhat different from the other one. It does this right here. And we'll say that's 1, 2, 3, and maybe my tick marks 1, 2, 3, and right here 1, 2, 3. Let's extend that till we actually hit -3 there. So this point is -3, 1. This point is +3, 1. And again, we concentrate on the x's to describe where the increasing, decreasing, and constant is happening. So as we look at this from here to here, we are constant. So from -3 for x to +3 for x, we are constant. Remember, we put the smallest number first and the larger second, and we give parentheses. And then we're decreasing right here. So we start with x is 3 and go on toward positive infinity, and again parentheses, and this graph is increasing nowhere. We're going to use a -7, 7, 1 by -2, 12, 1 viewing window to graph this function. Now, what on earth does it mean to have a -7, 7, 1 and a -2, 12, 1? It means that the x has a minimum of -7, a maximum of 7, and each tick mark is 1. These are the y's. Minimum y is -2, maximum y is 12, and each tick mark is 1. And we're going to type in absolute value of x squared minus 9 for our first y on our y list. So let's go to our calculator and start typing. We want to put in absolute value of x squared minus 9. Now, where do we look for absolute value? Let's look under our math screen, go over to numbers, and notice ABS. ABS stands for absolute value. So I'm going to hit enter, and notice it puts absolute value up here in my equation. And now I can type in x, this is our variable x, as opposed to multiplication here. So go back to x to the little housetop, second power minus 9. And now we want to let the calculator know that we're at the end of what's in the absolute value, so we'll put parentheses, and that tells it we're through with that. Now we want to go change our window. So let me show you what your standard window looks like. That's selection 5. Okay, and now let's change our window here. So if I go to zoom, 6. Zoom standard, that's selection 6. I get a standard window. But we were asked to have a different window in this problem. So notice when I click on window here, I get x-min as -10, but I want the minimum to be -7. Now I use this little fella right here to indicate a negative number. This is for subtraction right here. So I put in a 7, hit enter, and then I want my maximum x to be a 7. And I'm going to leave the x scale at 1. Each tick mark is 1. I want my y minimum to be -2. My y maximum to be 12. And each tick mark can stay at 1. So now let's graph this. And we see a little bit bigger version of what we had a few minutes ago. So let's describe where this is increasing, decreasing, or constant. So looking at this, I would say that we are decreasing right here and right here. So we need to know our ordered pair here, or at least the x of it. So, and right here we need to know that x, and right here we need to know that x. Well, this one's pretty easy, isn't it? That looks like a 3 to the left, so we'll write -3 then. 0 for y. This looks like 3 to the right, so +3, 0. Now this looks like 1, 2, 3, 4, 5, 6, 7, 8, doesn't it? For y, and of course x is 0. So now I'm decreasing here. From -infinity, because x just keeps on going, -infinity, comma, up to -3. And then I jump over again and start with 0 for x and go to 3 for x. Sometimes you'll see a comma between the two intervals. Sometimes you'll see the union symbol between the two intervals. So we have interval notation. The smaller number, if there is one, or -infinity if not, and -3, both use parentheses. Then let's see where our function is increasing here. We're increasing from -3 to 0. And we're increasing right here from 3 out to positive, or towards positive infinity, and use either a comma or the union. And of course constant, we have no intervals where it is constant. Okay, that concludes our increasing and decreasing functions for right now.